Let's have a look at the extract from a data book now. So what I do here is I imagine that glucose is bad for you and I put a big cross. And I know that the OH is here and the OH is here on the phosphate, and the 2-deoxyribose bond with each other because the OH and an OH makes water and leaves an O left over as a link, as a bond. So this OH, this phosphate here with the top OH, links onto the bottom OH of a 2-deoxyribose, and the bottom OH of another phosphate links into the top OH of one of these here. I'll explain what this one does and what these bases are all about in a minute. So let's have a look at the question. The question says, using the information from the data book to help you answer this question, work out how a single strand of DNA is made from nucleotides linked together. So I've got a phosphate, and then I've got a 2-deoxyribose, and then I've got a phosphate. And we've talked about the fact that this OH and this OH here bond, so a phosphate above using the bottom OH linking to this OH, and a phosphate from below using its top OH linking to the bottom OH here. It doesn't really matter which O and H's are lost. You lose two H's and an O somehow or another from the OH and the OH, and then again here, and therefore if I remove an H and an OH, doesn't matter which H and OH here, I end up with this. So the H has gone and the OH has gone, the OH has gone and the H has gone, and then when I link them together with a drawing by putting a bond in, an O to a CH2, and then this bond extended down to the O, I have got my phosphate 2-deoxyribose phosphate link. Now it says that the structure of a nucleotide that contains guanine links on. So let's have a look at these bases. These bases link on to the phosphate 2-deoxyribose phosphate, so the main strand of the DNA. The bases link off it, and they use the NH at the bottom. So you find the NH from your data book on the bottom of each of these, and it's the NH that links to this OH here. So this OH here on the 2-deoxyribose links to an NH on a base. And no prizes for the fact that the O and the H and one of the H's, OHH or H2O, are made, and therefore you rub out an OH and an H and it leaves an N to a carbon link. Let's have a look at that now. I'm going to use guanine because there's guanine in the question, and I'm just going to turn it round. I'm just going to rotate this. Forget about what the other circles are for. We'll do that in another part of the question. This NH here, or this NH here of thymine, cytosine, thymine, and adenine, could be the same thing. This NH, let's have a look. This NH, I've just rotated guanine so I can get in the right orientation. This NH links with an OH, removes the water, so I've drawn it again without the water here. I've removed the water, so I've removed an H and an OH here, and now I'm ready just to put the link on. I've left the rest of it the same. So I've removed the H and the OH, and now I'm just ready to put the link on. And you could do the same, so if you're asked for adenine or cytosine or thymine, you could do exactly the same. It just rotates round slightly, or you can flip it, so flip it over left to right, turn it left to right, transpose it left to right to get it in the right orientation here.